This session is on Kutta method, or fourth order RK method. Please look at part 1, 5, 6 and 7 for better understanding. We will look at how to derivate formula and how to solve ordinary differential equation at a particular point from the initial condition. And we will solve one of the problem on Kutta method. Please like, share and subscribe this particular channel. Come to Kutta method of fourth order RK method. Okay. In this case, they would be giving the value of an y dash, which is equal to nothing but f of x comma y, and that will be giving the initial condition that y of x naught is equal to nothing but y naught, and they would be asking the value of y of 1 is equal to how much. If you see the Faber's Euler's method or modified Euler's method, okay, here would be getting lots of error, and this one you may or may not get the value. Exact value may or may not be there. Okay, to get the exact value we'll be using in a Kutta method. Here y of 1 we'll be finding out is equal to nothing but y naught plus h into average of an 4 slopes will be constrained by using in a Kutta method. By modified Euler's method we'll be considering only 2 average slopes, right? If you want to understand more, please look at the modified Euler's method. Okay, if you consider this particular graph, this is nothing but x-axis, this is y-axis. If you consider function as this particular format, okay, function is in this particular format, I mean assuming it, okay, and this is nothing but an x naught, and this is nothing but an y naught, right? Now in this one we consider value of an k1, which is equal to nothing but h into f of x naught comma y naught. This is nothing but an slope, yes or no? And if you consider this point as an k1, now we'll be considering one more slope as k2, which is equal to nothing but h into f of x naught plus h by 2 comma y naught plus k1 by 2. What is h value? If we consider a point here, this one is an x1 and half of it h by 2. Okay, distance between these two is nothing but h. It is known as the step size. Okay, and half of the step size when we consider one more slope. Okay, and when we multiply with h, we consider this point as an k2. If you could draw in a graph of it, okay, slope of it of k1. Now we'll be considering a point here, and we'll be finding the one more slope. If you consider this point as an k2, then we'll be finding the value of k3 also, which is equal to nothing but h into f of x naught plus h by 2 comma y naught plus k2 by 2. This is also a slope, yes or no? And we'll multiply with an h, right? If you draw one more slope at k naught plus h by 2, okay, at this particular point, you'll be getting one more point here, yes or no? If you consider this point as an k3, again what you do is nothing but find the value of an k4, which is equal to nothing but h into f of x naught plus h comma y naught plus k3. Okay, here x naught plus h is nothing but x1, so at x1 we should get the value of somewhere here as an y1, as a no, we have to get the value of an y1 only. Y1 is nothing but when we get the value of at x1 and y1 only, right? So for k4 also we'll be finding the slope at x1, right? So in the point B here somewhere, if you consider this particular point as an k4. Okay, now to find the value of y1, what we do is nothing but average of an slopes, which is equal to nothing but y naught plus, it is a y naught, plus we have to add some value here, right? The extra value here also, right? So plus we'll be adding k1 plus 2 times of an k2 plus 2 times of an k3 plus k4. So average of it is nothing but 1 by 6, as there are 6 terms, right? 1, 2, 3, 4, 5, 6. So we'll be considering 4 slopes, but we'll be taking average by 1 by 6, as would you multiply with 2 for k2 and k3. But this is nothing but again an average slope. So we'll be drawing one more slope. This is a slope of it. So we'll be getting the exact value of an y1 here. This is nothing but a Runge-Kutta method. So formula just note it down. Okay. The formula is nothing but y5 plus 1 is equal to y5 plus 1 by 6 into k1 plus 2 times of k2 plus 2 times of k3 plus k4. Where k1 is equal to nothing but h into f of x of I, y of I. And k2 is equal to h into f of x of I plus h by 2, y of I plus k1 by 2. And k3 is equal to nothing but h into f of x of I plus h by 2, y of I plus k2 by 2. And k4 is equal to h into f of x of I plus h, y of I plus k3. Where I is nothing but equal to 0, 1, 2, so on. And h is nothing but a step size. Okay, this is the general formula of a Runge-Kutta method. It's very important. Okay, just remember it. Now we'll be solving one other problem on it. Now coming on the question on Runge-Kutta method. The question is, consider f of x comma y differential equation if y is equal y naught at x is equal 0 using Runge-Kutta method. A step size point to incremented value of an y is. They are given the differential equation dy by dx is equal to 4x plus 4. So they are given the initial condition, right? X naught is equal to nothing but 0 and y naught is equal to nothing but y only. And they are given the step size h, which is equal to nothing but 0.2, right? And they are given the differential equation dy by dx, which is equal to nothing but f of x comma y, which is equal to given as 4x plus 4, right? And they are asking for incremented value of an y, right? So y1 will be incremented is equal to nothing but y naught plus some value of an incremental value. We have to find this particular value. The general thing that we know by Runge-Kutta method, formula is given as y1 is equal to nothing but y naught plus 1 by 6 into k1 plus 2 times of an k2 plus 2 times of an k3 plus k4. As I know. So we have to find the value of k1, k2, k3 and k4. Here the value of an k1 is equal to nothing but h into f of x naught comma y naught, right? X naught is given as nothing but 0. Y naught is nothing but y. What's the function here? Is nothing but 4x plus 4. So we'll substitute the values. H is given as 0.2 into 4x plus 4 means x is 0. So it becomes 4 into 0 plus 4. So it becomes 0 here, which is equal to 0.8, right? So find the value of an k2 now, which is equal to nothing but h into f of x naught plus h by 2 comma y naught plus k1 by 2. So here x naught plus h by 2 means it becomes 0 plus 0.2 by 2, right? There is nothing but an y naught plus k1 by 2. But here value is not there, right? Y value is not there. So we consider only x values. So it becomes 0.2 into 4 into x value, it becomes 0.1 plus 4, which is equal to nothing but it becomes 0.88, right? So again we define the value of an k3. The value of an k3 is equal to nothing but h into f of x naught plus h by 2 comma y0 plus k2 by 2, which is equal to nothing but 0.2 into 4 into x value is nothing but x0 plus h by 2, 0.2 by 2, 0.1, right? So it becomes 0.1 plus 4. Now the value is nothing but it gets us 0.88 only, right? Again we define the value of an k4, which is equal to nothing but h into f of x0 plus h, comma y0 plus k3, which is equal to nothing but it becomes 0.2 into 4 into 0.2 plus 4. We get this particular value as 0.96. Now we have to find the average of it, right, by 1 by 6. So we get the value as nothing but 1 by 6 into k1 as 0.8 plus 2 times of an 0.88 plus 2 times of again 0.88 plus 0.96. We get the value as 0.88. So here we can say that y1 is equal to nothing but y0 plus 0.88. So incremental value of an y is nothing but 0.88. So the value of an y has been increased by 0.8. Answer is 0.88.